Hi, so today I'll be talking about my big project in quarter 2.
This project aims to see and understand about the relationship between pressure and volume through Boyle's law theory. By that, the result of this project will then explain how the relationship happens between pressure and volume and why did it happen and what is actually the Boyle's law. Throughout the experiment, question and practices and also experiment will be done based on the relationship between pressure and volume to show examples and prove the Boyle's law theory. So, as a background information, during around mid of the year 1600, Robert Boyle studied the relationship between pressure and volume at a constant temperature, and he found out that at a constant temperature, the pressure and volume for gas is almost constant. So he came up with a theory that at a specific temperature and having a specific amount of gas, the pressure and volume will be constant. This is shown through a formula P times V equal to N times R times T. This formula stated that pressure and volumes are constant at a constant temperature, and pressure and volume are inversely proportional. So at the beginning of this project, I have started with researching for information about Boyle's law, and as soon as I get the information as much as I want, I start with one practice and then another experiment. So the practice was the graph. So first I got a set of data which showed the pressure and volume table. And so I took that and put it in GeoGebra and graph it out and see the connection between pressure and volume. The result came out that volume and pressure are inversely proportional. So as volume increases, pressure decreases, and as pressure decreases, volume increases. And it also showed that at a specific point or specific time, there will be a specific volume and specific pressure. We can use the graph to also predict what will be our pressure and volume at this time, at what time we want, from the graph we have come up with. It is a power function graph. Why is it a power function graph? Because when we're graphing it out, I've tried using all the possible graphs, and the power function graph is that one graph that the line actually goes through every single point on the graph. And it actually shows that pressure and volume are inversely proportional. So it's a very useful graph. We can use it in our real life. One is the experiment, which I use the siren for it. So during the experiment, I have done it two ways. The first way is closing the tip of the siren and try to push the puncture of the siren in and see what happens.